that the mass of this is 0.74 grams. Wait, 746. Pressure is 1.4. And then the temperature is 47.2 degrees Celsius. But every time we do PV equals nRT, we have to change it to Kelvin. So add 273, and you get 320.2 Kelvin. And you know that your molar mass is 32.00 because it's oxygen gas, which means it has to be diatomic, right? So the density formula is given by molar mass times pressure over RT. So we know our molar mass times the pressure of 1.4 atm over RT. And you should get so the mass is irrelevant at this point. They just give it to you because you just need the molar mass, right? So
it's like a trick question. Like, it's unnecessary.
kind of, yeah. They just give it to you because if you did use it, then you would get your answer wrong.
So do you recommend that we first write out our givens and then think about formulas?
Yes. Because if you write your givens down first, then you know what you have and what you don't have. Because sometimes if you don't write your givens down, you might pick a formula that has two unknowns, and then you won't be able to go anywhere with that.
Okay.
Could you also do like for density to mass over volume instead of equal to that, and then plug the mass that they give you into that, and then get the volume just plug that back in and multiply by volume? Where are you going in?
That's what I tried to do, but I couldn't find out how to get volume by itself.
Let's see what you mean. Okay. So we have a mass of 0.746. You could just change this straight to moles by using the molar mass. But this would be like extra work. So 0.746 divided by 32. So that's n, right? N equals 0.0233. And we have P. So if you had done this and you solve out for V using PV equals nRT,
Okay, I just said it like m over v equals pm over rt,
yeah,
and then just solved it out.
yeah, that's right.
Okay.
Well, because, okay, if you did that, M over V,
Yeah, and then I had to plug the exact thing to get to this. Then I did the math for that.
yeah, so this we'd have to multiply by the molar mass to get density, right? Because, well, you're given, like, okay, wait, hold on. So repeat what you're saying again.
No, I was just saying, I said it like M over V equals P1 over RT, and solved for V because we already have the mass. And then when I got V, I just did like mass divided by V.
You could do that. Yeah, because you have the mass, so why not? Or you could just solve it like the other way. But yeah, either way works.
Okay. What was the answer?
I think the answer was I got 389.958. What? Okay. So 1.4 times 32, right? Divided by 0.08206. Divided by 1.4.
No, divided by 320.
Oh my gosh, you're right.
Oh yeah, you're right, but she's also right. It's like
It's.
in the denominator it's 10. But like when you put in the
Did you get 1.7? Yeah. Okay, that's your answer.
So can you start that problem over?
Yes, I can. I'm just going to do it the original way I did it, and then we'll move to the next question.
So you're not using the given graph, right?
No. Times pressure. That should be your answer. Okay, I'm gonna move on to the next question. Is everyone good with this one? Yeah? Okay. Okay, so then,
Where you got the formula itself from.
yes.
Density equals MP over.
So if you have PV equals nRT, you know that density is equal to mass over volume, right? The closest you can get to this is going to be
You change the N into
N over V, right? Because you get moles over volume. So then you get pressure over RT. But if you want to have mass over volume, you're going to have to use molar mass. So if you multiply this by the molar mass,
which is moles.
grams over moles. So you have moles over liters right now, and you're multiplying by grams per mole, which is your formula for density. So
Equals mass over volume.
yes.
So when we solved it, we got volume because we already had the mass. But then to get density, wouldn't you have to make the mass divided by the density by 10?
So I didn't actually use the mass. That was just given information, so if you want to do it your way, you could, but
But I got a different answer for you, so I'm confused.
Like the correct answer is 1.7.
yeah.
Can you solve it that way?
This way?
Just to like
That's like the fastest way you would say. Like, the most straightforward.
Yeah.
That's actually a density equation.
yeah.
That's given in the chapter, the one she did.
What's the
Between yeah, the P over RT times molar mass is the equation for itself.
Oh, no, use a different equation.
Oh, is that one
We're
the
using
density
Chem
is like
1B.
weird?
This one?
No, the M over V is one that I feel like we're using Chem 1.
Yeah. You're not really using this, it's just to derive it from that, basically. I'm going to solve this at the end. We'll do it at the end, okay? Okay, next question. Okay, the next question is, describe the relationship between volume and pressure in Boyle's law. So we know that Boyle's law is P1 V1 equals P2 V2, which means that V is inversely proportional to P. So that would be the answer to that. I'll just write it. Okay, if the pressure in a closed system is double, how would the volume need to be changed in order to maintain the system in equilibrium? So if you double the pressure, so we could say P2 is equal to 2P1, right? So we plug that in, and then we solve for V2. The P1s cancel out, and we get V1 over 2. So we know that the volume would have to be halved. If you think about it here, if you're multiplying this by 2, you have to multiply this by 1/2 in order for it to cancel out and be 1 and to get the same value. So it's in equilibrium.
What's
That
the
makes
same
sense.
denominator there? It says 2P1, right?
Yeah. Does that make sense?
Yes.
Okay.
Wait, why did 2P1 not 2P2?
Because they said we double the pressure. So we double the pressure, P2 is equal to 2 of P1. Okay.
So in words, you would have to just divide volume by 2.
Yeah. Okay.
You have titration stuff on here?
That's Chem 2. Pretty sure.
We have
Titration.
We have titration dilution problems in one chapter.
Really? Chem 1A?
Yeah.
Oh, no, 1A. This is 1B, right?
Yeah.
So, in like the overall Chem 1.
I'm just doing Chem 1B stuff. But
But the Chem 1B exam has all the Chem 1A stuff too, right?
yeah, but there are Chem 1A sessions.
I know.
This is Chem 1B. There's
Yes.
Chem 1A. If you wanted the Chem 1A as well, you have to go to there.
Thank you. Okay.
They've seen both.
Okay. Yes.
Okay.
Yeah, that's fine. Okay. I'll start in here and just move. Okay. All right, next question. How many grams of water form when 2.6 liters of H2 gas at STP completely react with O2? So we're going to go about this question. So we're going to start with liters of H2. We're going to convert that to moles of H2. Moles of H2O, and then grams of H2O. Okay, so we started with 2.6 liters of H2. And if a gas is at STP, we know that we can use the molar volume. So that is the molar volume, right? And then we're going to use stoichiometry from the equation. This is the equation. Right, so we know that for every 2 moles of H2, we have 2 moles of H2O. And from here, we're going to convert this to grams of H2O. So we know that 1 mole of H2O is 18.00 grams H2O. So if you calculate that out, you get 2.089 grams of H2O. And that should be your answer. From that, you just know SEP, so you use molar volume, which is the point of that question. Okay, number 6. All right, in alcohol fermentation, yeast converts glucose to ethanol and carbon dioxide. Calculate the volume of CO2 formed at 27 degrees Celsius and 1.3 atm when 47.9 grams of glucose is decomposed. And they gave us this formula. Okay, so for this one, we have to use the grams of glucose they gave us to find the moles of glucose. So if you calculate the molar mass of glucose, you should get 180.156 grams per 1 mole, which gives 0.2658. So from here, we know that they give us pressure and all of that, so we're going to use PV equals nRT. So we know that pressure equals 1.3 atm, N equals 0.2658 moles. Volume is, we don't know that. Wait, hold on, I skipped a step, but we'll go back to it. Temperature is okay, so if you notice in the question, they gave you the grams of glucose, but they want to know what the volume of CO2 is. So the rest of the stuff stays the same, but you would still have to convert the moles of glucose to moles of CO2. So if you did this, it would be 1 mole glucose over 1 mole CO2. So you still get the same number, but you still have to convert it. So solving for V, you get nRT over P. And you should get a volume of 5.035 liters. We're good for that question? Okay. Is it okay if I erase the first one?
What is that above the 1 mole H2O? Is that an 18?
Yes, sorry. Okay.
Would you say the easiest is split like half math and half conceptual, or is it just like a mix of?
I'd say, I mean, there are math questions, but especially with the Chem 1A stuff, there's a lot more conceptual stuff like diagrams that you want to look at.
I haven't seen the ATS questions yet. I have an example when you check that.
Can I look that up here?
Sure, yeah, you can just pass them around.
Yeah.
Are the same every time.
It's going to be the same if you convert everything to liters, ATM, moles over K, then it's the same R.
Can you always convert everything to that?
Yeah, like if they give you pressure in mmHg, you just divide it by 760, change Celsius to Kelvin by adding 273. But yeah, everything should be able to convert to that, so you don't have to memorize all the R's.
So do they give you the
Wait, guys, I can't hear.
Yeah, I don't know about your class though.
Okay, I'm moving on to the next question. Okay, a sample of nitrogen gas occupies a volume of 8.8 liters at 730 mmHg at 278 Kelvin. Calculate the grams of sample present. So we know that pressure equals 730 mmHg. So this is where one we would convert it to. So we change that to 760, so we would get that in ATM now. I could change that. We know that the volume is 8.8 liters. We don't know the moles. R is 0.08206. Temperature is 270 Kelvin. So PV equals nRT again. N equals RT over PV.
Isn't N equals PV over RT?
You're right. My bad. So we should get N is equal to 0.3815 moles. But in the question, I think they ask you for how many grams of sample are present. So they already told you that it's nitrogen gas. So nitrogen gas is going to be N2, which means the molar mass is going to be 28. So we're going to use the molar mass and convert this back to grams. You should get 10.682 grams of N2. Should be your answer for that one. Okay. Is there any questions on that one?
The conversion factor is 1 ATM over 760 milliliters per liter.
Yes, 1 ATM is 760.
And towards the same thing.
Yep. Okay, the next question says, which is the strongest of the intermolecular forces? London dispersion forces, hydrogen bonding, dipole-dipole, or ion-dipole? So the strongest out of those is going to be ion-dipole. If you put it in like order of strength, it's going to be ion-dipole first, and then hydrogen, and then dipole-dipole. And then London dispersion forces.
Why is it like that again?
So ion dipole is going to be the strongest because ionic bonds are the strongest, and ion dipole is like the most similar to an ionic bond. And then hydrogen bonds are just stronger than dipole-dipole, something you would know, you should know. And then London dispersion forces are going to be the weakest. They're found like within like any and everything.
It's Dipole is for covalent bonds?
Yeah. Right.
Oh, no, I think that is the right order.
Dipole is for polar bonds.
Hydrogen ion are just a type of answer.
Okay.
Yeah.
Yeah, but ionic is the stronger stuff.
So we don't need a scan shot for the exam? No, you do.
I assume you do, yeah. Yeah, I don't know. That's just the, it's like a sign someone, yeah, exam. I mean, the actual questions on there are what we're looking at.
It's supposed to be really, really fast. I'm so used to like kind of concept with rules and like.
Yeah.
It's
Like,
not like long so one of the basics.
you look at it like
Yeah, like our teacher gave us one for, are you talking about? Yeah, like hers, that's kind of like, it's like a four, like 3 to 4 steps.
What I noticed with ACS, the concepts themselves are pretty simple, but they're rewritten in an unusual way. Like,
Okay, so
what we
it's just
not
the word
doing-
that makes it.
Yeah, like, they're not working on something hard.
I lost my periodic table. Okay. So the next question asks for Lewis structures, electron geometry, molecular geometry, angles, and hybridization. So we're going to start with drawing the Lewis structures first. So A is HCN. So when drawing Lewis structures, the first thing you do is count out all your electrons. So 1 plus 4 plus 5. We have 10 electrons. So we know that carbon is going to go in the middle, and hydrogens are always polar.
Is it like the reason, what's the reason again, like to figure out like
The least electronegative is going to go in the middle, and the most electronegatives are always going to be at the end. So we know that carbon's in the middle and nitrogen and hydrogen on the side. So the first thing we're going to do is fill in the shared electrons. So we've used up 4 electrons, and now we want to fill the octet. So in order for carbon to be satisfied, it's going to want 4 bonds too. So we're going to give nitrogen and carbon a triple bond, and then nitrogen's going to have a lone pair. So basically, your Lewis structure will look like this. So we know we have an electron geometry of linear and a molecular geometry of linear. This is because carbon only has 2 electron groups because it's bonded to 2 things. So because it's linear, angles are going to be 180 degrees, and then hybridization is going to be SP because it's 1, 2. Yeah. So hybridization is basically counting the electron groups. So if you have, okay, say we're taking HCN. So this carbon is bonded to 2 different things, which means it's going to have, this is 1 electron group and that's 1 electron group. Say a carbon had like,
do you look at it just like on the side of the atom?
yeah. So say it had 3 bonds and a lone pair. That's 1, this is 1, this is 1, and this is 1. So that would be sp3.
And S is only ever just like one.
Yeah, so basically you can think about it is like 2 electron groups is going to be sp. But you never find something with 1. I don't think you would. Basically, that's how you would do that. Okay, so the next one is
What is diphthalate hydrogen?
What?
S?
There's no central atom in that, so I don't think you would do a hybridization for that because it's not really hybridized. Okay, so drawing the Lewis structure for this. So we know carbon goes in the middle because it's the least electronegative. Oxygens are on the side. So we fill this first, and then we fill the octet for, and we know this should be 4 plus 6 times 2, 16. So we have 1, 2, 3, 4, 5, 6, 7, 8. So we have our 16 electrons on the board, but carbon doesn't have its full octet. So now oxygen's going to share it. So we get that instead. So our end Lewis structure should look like this. So we know carbon, again, has 2 groups. So electron geometry, again, is going to be linear. Molecular geometry is linear. The angle is going to be 180 again. And hybridization is going to be SP. Okay, so for C, we have H2O. So we know hydrogens are always terminal, so we're going to go at the end. Hydrogen, hydrogen. We have 8 electrons, so fill these first. And we know that hydrogen can only have 1 bond, so those are good. And then we fill the rest for the oxygen. So our Lewis structure should look like this. So this oxygen is bonded to 2 things, and it has 2 lone pairs. So that means that its electron geometry is going to be tetrahedral. Molecular geometry is going to be bent because it has 2 bonded and 2 lone pairs. Angle is going to be less than 109.5. And the hybridization is going to be sp2. 3. Yeah. Okay. Let's see. So D gives us BrF3. So you know Br has 7, and fluorine also has 7, which means 28. So we're going to fill these first, and then give full octets. But we still have extra electrons left over, so we add it to that.
Which ones are the ones with the expanded octet rule? Is it easy to cite?
Start off first. It's fine. You should try on your own. And less than 8. That's this. So like aluminum's not doing 6 instead of 8. Something like that.
So we know the hybridization is going to be sp3d for this because it has 1, 2, 3 bonded pairs and then like 2 lone groups, which is 5. So basically you can tell your hybridization from your electron geometry. And then the last one is NH3. So N goes into the middle because it's less than 90. Okay, so N goes in the middle. Right, so we put our bonded groups, that's 6, and then N has a lone pair. So our N Lewis structure should look like this. Electron geometry is going to be tetrahedral because 4 electron groups.
Trigonal pyramidal is when there are 5.
Yes. Bipyramidal, yes. Did I write something wrong?
Pyramidal if there's 4.
There's 5.
There's 5.
Wait, I'm in for N H3.
Did I write that wrong?
Wouldn't it be trigonal pyramidal?
Yeah.
Quadrupyramidal and pyramidal are different.
Yeah.
How so? Or I think I have a sheet for that.
Yeah.
Bipyramidal is 5 electron groups, 2 lone pairs, and trigonal pyramidal is 4 electron groups with 1 lone pair.
I think I remember that.
It's like binomial equation, so instead of having 1 lone pair on trigonal pyramidal, you have 2 pairs.
Exactly. Hmm? I don't remember. That was like a year ago. I only remember the Chem 2 one. My bad. Okay. It's really bad. Okay. Okay, so we're going to move into the next question. The next question says, what is the electron geometry for a molecule that has 3 lone pairs and 2 bonding groups? So that's going to be trigonal bipyramidal. And then it asks for 3 lone pairs and 1 bonding group, and that actually shouldn't exist.
Was it supposed to be the other way around?
If it has 3 lone pairs and 2 bonding groups, it should be trigonal bipyramidal, but 3 lone pairs and 1 bonding group shouldn't even be a thing because
No, it's trigonal pyramidal.
with 1 bonding group and 3 lone pairs?
It's the other way around.
Yeah.
One bonding pair is 1 lone pair.
Yeah, if it was the other way, then that would be right. But something for to have 1 bonding pair and 3 lone pairs wouldn't exist because, like, just, yeah. Probably not, but, like, just make sure that you look out for, like, which one's the bonding group that they say.
I think the max amount of lone pairs is like 2. At least for the scope of our class.
Yeah, probably, yeah. Okay, we're going to move on to the next question. So the next question is going to be bond energies. So this combines everything that we just did. Okay. So we know that when we form bonds, there's going to be energy being released out of it. And when we break bonds, we have to put energy into it to break the bonds. So we know that this side is going to be positive because it's endothermic. It needs energy to break them. And then this side is going to be exothermic because energy is giving off when they're formed. So the first thing we're going to do is draw the Lewis structures. So to make sure we have like the bonds the right way. So that's going to be for CH4. Cl2 is just going to be a single bond because chlorine has 7 electrons. And then carbon. And then there's a single bond between hydrogen and chlorine. So now we count the bonds. So there's 4 CH bonds, 3 Cl bonds, so I just realized that I didn't give you guys the bond energies, but if you have the worksheets that she gave you or anything, you could look on that. They should all be the same. So we know that CH bonds are going to be 413 kilojoules per mole. Cl bonds are right. And we're going to subtract the N side of it because we know that that's exothermic. So basically we can just add all this side up and then subtract it. So 3 times carbon chlorine bonds. One carbon hydrogen bond. And if you add all that up, you should get that as your answer.
So anytime they ask for like that thing, it's basically just draw the Lewis structure, like see how many types of bonds you have, then plug it in and subtract the products from the reaction.
Yes. So you always subtract products from reactants. Wait, explain. You want to explain why you subtract products from reactants? Okay.
Oh, you want me to do it?
Yeah.
Oh, I don't know.
Okay. So the products are always going to be subtracted because when you form products, there's always energy being released. So releasing energy is exothermic, right? And exothermic is going to be negative, which means you're losing energy, which is why you subtract it. Because the bond energies are always going to be given to you in a positive form. So it's like the bond energy is how much energy you need to break it, basically.
Okay.
But it's opposite for when you're forming it.
So exothermic reactions are always negative?
Yes. And endothermic is always positive.
Can you explain about like the positive and negative ones?
I think a good way to remember is if you think like system and surrounding, right? They teach you that way. Like so, if it's exothermic, it goes from the system into the surroundings. And if it's endothermic, the heat is coming from the surroundings to the system. In the entire like Chem 1 and Chem 2 in all these courses, we'll always see like in the perspective of the system.
Okay.
So, you know, that helps me visualize it.
No, yeah, that makes
But
So if you're looking at energy levels, you can see here an exothermic starts at an energy and then ends lower. So when you subtract it, there's like a negative value, which is why you have energy being released. And then for endothermic, you're not, like, the energy goes up. So you subtract it and you get a positive value because energy is being released. If that makes sense. Okay. So the next one, can I erase this? Is everyone good for this? Yeah. Okay. The next one is H2 plus Cl2 Right, so we know this is two of the bonds and an HH bond.
This would be something they would provide with the bond, right?
Yeah, these numbers. Yeah. So that should be negative 184 kilojoules per mole. And then
So in total, there are 4 HCl bonds, right? Because one HCl has 2 H and Cl bonds, and there's 2 HCl in total.
there's only one HCl.
Wait, it's balanced as, why is there 2 for the HCl? In the
Oh,
balance-
okay, wait. There are two HCl. So like
Yeah.
the bond itself is HCl.
Yeah.
Yeah.
One hydrogen chloride or hydrochloric acid, whatever it is.
Yeah.
It just has the H and the Cl and one bond between them.
Yeah.
Okay.
'Cause if you think about it, like,
Hydrogen can only form one bond.
right, and chlorine only needs one extra electron, so it only form a single bond.
Okay.
So this one is a good example of why you should always draw the Lewis structures first. So you know that these are just going to be single bonds, but if you're rushing through it, you might say that oxygen is going to be a single bond, but really it's going to be a double bond if you think about it, because that's 12 electrons, right? And you share that, and then you fill an octet. 8 plus, wait, there's too many. What did I do?
If you do it like that, it'll be 14, so that makes
Yeah, so this one doesn't have a full octet, so this is going to share it. There, so this is why oxygen is going to have a double bond and then 2 lone pairs. That makes sense. Let me fix those.
So when you would like calculate the bond energy, you would do like 2 times the bond energy for oxygen double bond.
So oxygen double bond actually has a different bond energy than oxygen single bonded. If you look at a like bond energy chart, that'll be different.
Oh, so it would, okay, if it was like 2 O2, then you would do like the bond energy for double bond times 2.
Yes, exactly.
Are there also different bond energies depending on what state the compound is in? Or is that delta H formation?
I think so. I don't think there should be different, not for bond energies at least. Okay. And then here's another example of double bond. So now we just use the numbers. So 3 carbon chlorine bonds. You should, but I think the examples I give just ended up being like negative for all of them. Actually, I think this one will be positive.
So when you're trying to list structures for these type of questions, you should still pay attention to the lone pair. Sorry, like the total number of electrons. You said.
Yeah,
Just
because
protons or doubles.
exactly. So that should be your answer for that.
This would be, like you said, like non-primary. So in that graph with the energy, like where is the energy like, in this system?
So the graph would look like an endothermic. Right? Because, right. If you do final minus initial, you're getting a positive value. Is everyone good with these? For which one?
The O2. I made that mistake.
Okay, so on to the next question. All right, so this one is a formal charge question. So the first one asks for formal charge of HCN. So here's where we want to draw our Lewis structures again. So we already drew this one before. So formal charge, you're going to find by doing the number of valence electrons minus number of non-bonding electrons plus 1/2 bonded electrons. Another way you could do 1/2 bonded electrons is just the number of bonds, basically. So if we look at formal charge for each of these elements, so if you look at carbon, so carbon has 4 valence electrons. The number of non-bonding electrons, there are no non-bonding electrons, and it has 1, 2, 3, 4 bonds. So 4 minus 4 is 0. Its formal charge is 0. We look at hydrogen. Hydrogen has 1 valence electron. 0 of them are non-bonded. That has 1 bond. Formal charge is 0. If we look at nitrogen, nitrogen has 5 valence electrons. There are 2 of them that are not bonded, and then there are 3 bonds. So 5 minus 5 is 0. So this would be a good structure for HCN because all of them are 0, and so that's like what you would view as a stable structure.
So that's a number of non-bonded.
Yes. Okay. So if we look at CO2, we draw the structure. We already drew it before. So if we look at carbon, again, it has 4 valence electrons minus 0 that are not bonded plus 4 bonds. And then the oxygens, 6 valence electrons minus 4 of the non-bonded plus 2 bonds, 0, and this oxygen is exactly the same. Okay, and then the third one, so we know that sulfur is going to go in the middle because it's the least electronegative, and then we have oxygen and chlorine. So if we count our electrons, should be right, fill in the non-bonding, fill the bonding, and then fill the octets. So you have 24 here, and then, wait, there, yes. Did I do the math right? Is that right? And then there should be, wait, 1 second.
Would the sulfur to the hydrogen be double bonded though?
It should be, yeah.
That's what I had down.
And then there's also a lone pair there. So sulfur has 6 valence electrons minus 2 that are lone, and then 4 bonds. 6 minus 6 is 0. Oxygen has 6 or 2 bonds. Chlorine and then the chlorine on the other side is also the same. So they should all have formal charges 0.
Just double checking electronegativity from like left to right and then down up.
Yes, it's just going to go like up in that direction.
And then electron affinity is same thing.
Electron affinity has a different like trend. The trends don't really. There isn't really like a set trend.
For which one?
Electron affinity.
Side to side, I know it like depends, but when it goes up.
Yeah.
It goes in the same direction, it's like a trauma gradient.
Which goes up.
Yeah. The exceptions. I don't have all of them memorized.
I think I have it now. You're on a table. Oh yeah, the only two that go the other way are atomic radii and processes.
Oh, okay.
Yeah, so I just say like
Just know that it's like,
right? That's right.
Yeah, okay.
I noticed like with a bunch of horizontal notice
So sulfur is an exception because it's in
like three
the things that are past. I think it's
this way, and the other stuff
yeah.
goes back this way.
Things that are past like group 3 are going to be like exceptions because they're a lot bigger. So that's how you know that it's an exception. So boron will be something that forms it that could last with like just 3 bonds. So there are some that are like below the octet, and then there's some that are above.
so it's like group 3A, they're all like below.
And then I know there are exceptions,
Those are just, like, I don't know how to explain it. Basically, you just follow that rule with the group 3A. Because they're just the set ones that you know have the exceptions, and you just memorize that.
But there's other ones that have exceptions too.
Like phos.
Even
Yeah, those are past, okay, let's
Past
see.
period 3, you can have an expanded concept.
Yeah.
So like past, we see where NA is, that this whole row, and past, you can have an expanded concept. So
Okay.
And then I think boron and before, like this group and before, can have
Less
under,
than.
yeah, because
So
they're
that's
small.
silly. They should just basically say that the exceptions are like the 5. Like,
Yeah.
what is that?
Yeah, I don't
I
know.
think a lot of bonds happen with these, like most of the time.
Yeah, true.
It's like these, right? Like these are the ones my professor had us circle.
On each of this sign and below, you can have an expanded concept, and then this row behind is below.
Okay. All right, I'm going to move on to the next question. Okay. Okay, so the next question is electron configuration. So we're going to do MN first. So basically we just find it on the periodic table and then start listing it. So it has 1s2, 2s2, 2p6, 3d5, right? Because it's the fifth one in the D block. So if you're doing the noble gas configuration, we would do argon, 4s2, 3d5.
Oh yeah, I had a question about
Okay.
the noble gas configuration.
Okay.
For some of them, I know it's like the half and half. Like,
The
for
5 and
example,
10, is it the one like where it's like vanadium, that whole period, and then
yeah, it'd be like 6
4s
S
and then
1 5 B.
Yeah, like what's the order? Like how does
Yeah, how do you know?
Okay, so if you once you get down to the D block, it's gonna go below it. So it'll be 4s 3d or 5s 4d.
what about those exceptions where like, so specifically vanadium with vanadium, it would be 4s1, 5d10, instead of being 4s2, 4d4.
I think that would be for chromium.
Oh, chromium? Okay,
Yeah.
chromium then.
So
Is that whole row?
yeah, I think
it's that, yeah, the whole column.
on your periodic table it goes like okay, 1s2, 2s2, and then these are 2p6, and then these two are 3s2, and these are 3p6, and this is 4s2, but this is 3d,
Exactly.
and then 4p6.
Right. So
Just know that the D's start at 3, and the 4s are going to be before it, so it goes 4s2, and then anything in here is 3, and then 4p6, it goes back to
if we were doing,
Metal starts, you started at 3Ds, but everything else is sort of continuous.
yeah, basically. So if we're doing chromium, if you like looked up the Is this what you were talking about? How that would be 3d5?
Yes.
So basically, instead of having, if you were to do it normally, you would say it would be 4s2, 3d4, right?
Yeah.
Instead of having a full S and having a 4 in the D, it would be better to have a half full D orbital than,
Because unstable or something.
yeah. So basically, this electron's just going to move there. So you change that from 4s2 to 4s1, and then it'll be 3d5.
So wait, what's the correct answer?
This is the correct answer.
Oh, I don't understand.
Yeah, that's what I was saying, because I remember you like moved it, and there's another row like that.
Yeah.
Right?
So it's the same thing for the end. So if we're looking at copper, 1s2, 2s2, 2p6, 3s2, 3p6. So instead of being 4s2, 3d9, it'll be 4s1, 3d10. 'Cause- yeah, basically, and the column for copper and the column for chromium, it's going to follow that rule.
Do you mean column as in like group kind of thing?
Yes.
Just chromium and those are the only ones. So, like if
That follow that exception.
so if we did like vanadium or whatever, it'd be like blah 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 4s 2 3.
Yes. Basically, you just want to fill it so it's like if you can fill it to the half and it's like that close where it's 4, then you would change it to be half of the D. Do you get that? So, okay, wait, let me. For this one, you don't really have to understand that per se. Okay, so we're looking at chromium, right? You get it?
Nothing, I was talking about, so the whatever atom it is, it wants its d orbital to, it really wants it to either be completely full or exactly half full.
Yeah, but it's only going to do that if it's at 4 or 9.
Okay. So
If you're-
very close to being half full or very close to being full,
Exactly.
then it'll just like break the rules.
Yeah, so chromium, if you do the noble gas, you would think, so this is the wrong one. This is not what it should be. This you would put 4s2, 3d4, right?
Yeah, that's like the
But it's so close to it that it would actually be 4s1, 3d5 because a half d orbital is much more stable.
So basically, if you're one away from either being half filled, which is 5, or fully filled, which is 10, then you just like remove it.
Yes, basically.
That's how Dr. Patino told us.
All the super important things, she just like barely mentions this. They don't think it's super important, but it's like, oh, that's literally how you do it.
What teacher is this? Is this recording?
Yeah.
Yeah, it is.
That's fine.
Okay. Okay, let's get back to this. Okay, so argon is going to be 1s2, 2s2, 2p6.
I'm not in your class.
So argon is just going to be So argon's just going to be 3p6. That's where it's filled, right? So C asks for SR. So this is going to be 1s2, 2s2, 2p6, 3s2, 3p6. Or if you did the noble gas configuration, you could just write. With the noble gas configuration?
Yeah, so would it be, okay, so that's what it will be, so if it's just the S, the half the orbital doesn't apply, the half the orbital, no, so it's those two rules. So it's only when it's S and D. Yeah,
Only
that's
when
it.
D is 4 or 9.
Okay, so that's only when that is, okay.
Yeah.
Just remember that it's just these two, like
Yeah, so
6B and 1.
They probably won't like test us on the exceptions in the F orbital, right? 'Cause I know there's
I don't think so.
Yeah, we don't have to worry about that. Probably.
So noble gas configuration, I don't know if you're asking about that, but basically you just pick the closest noble gas from like that was behind it, and then you just start from there. Because like this is just basically representing all of this, because that's what krypton is.
Wait, what is the thing in front of 5?
Yeah, sorry, they look the same.
And you just like continue it like normal, as if like you filled that like as if you wrote out everything.
Yeah, because this is just saying, like this is representing of that. So, okay, so D is potassium 1+. So if it's 1+, this means it lost an electron. So basically, it's going to be 1s2, 2s2, 2p6, 3s2, 3p6. right?
Wait, how do you?
Because potassium without an ion, just plain potassium,
It's just argon.
So yeah, so you would just like move it back, like how just things work with that.
yeah, you're just taking one electron away.
Whenever we were doing like atomic radius or something,
Mhm.
it would all be ones that like when you account for the ions, it would be the same element.
Right.
They
So
were all like
the isoelectric series thing.
Yes,
Yeah.
What is that?
So if you look at potassium 1 plus, you look at this electron configuration, this is exactly the same as your configuration for argon, right?
or calcium.
Exactly. Because calcium 2 plus, you're taking away 2 electrons, so you're getting back to argon.
When she like when we were doing atomic radius, like put them in order from like increasing atomic radius, she would give us like K plus, Ca2 plus, and argon, and say like put them in order for increasing size, like how would you do that?
So
Yeah.
that, okay, let me see.
Like you just look at it as its own normal thing.
Are you talking about stuff like this?
That's actually
S, but I
a
got
pretty
it.
complicated
I know
thing.
stuff like
Yeah.
that. Yeah,
It's
that's
on
not
there.
just
It's on that. She posted the answers for that, right?
She did?
In OneNote.
Yeah, but she didn't. Yeah, she didn't put like the last one. Yeah.
Oh yeah, it's like I remember those questions. It's counterintuitive. Like you're talking about.
Yeah.
So what chemistry you take?
I take like I take chem one. So
So you take 2045.
Okay, but tell me why Chem
Oh,
1
no, you
is
know
also
this.
on
You
the
need to be
20 final if we
here.
already took a final for Chem 1.
Because ACS like combines it. It's basically just a Chem 1 final.
Taking a final for Chem 1.
Or we should just combine both. It's a separate.
Well, you said it. You take Chem 1 because that's what that is. Yeah, but I'm too
alright, so listen. So you're talking about like it's like nitrogen and oxygen.
I can post it after. Okay. That's fine.
Which one has the higher radius? That's the question. So you would assume like
You would just look at it out loud based on the range.
yeah, you look at it based on so if electrons are the easier, then you would get protons, right? So you would assume that the one that has more protons, that it has more protons, it has a higher radius, but actually the opposite is true. Because oxygen has more protons.
So nitrogen would be.
Yeah, the
So
oxygen.
like N plus would be.
Are you talking about this question?
I meant N minus.
Alright, so if there's like same amount of electrons, so like one has more one more proton and the other one has one less. So we're gonna have more protons, we'll have to more protons and then can use
I'm gonna keep working.
and that would pull the electrons in.
Wow, you really understand chemistry.
Okay, wait a minute. So it's opposite. So the ones with negative charge will have the larger atomic radius.
No, not necessarily.
Compared to its own.
He's just giving the background information. He's not saying like a
I'm
general.
not even teaching anymore.
Every question is like something you don't know.
What you got in 2045?
Works for me.
What you got in 2045?
What's my grade in 2025? I don't know.
Can you go on
It's lost on web sources.
Can you go on fourth letter?
I'm gonna assume
Oh my god. I can't with you.
we should have been friends when I first started this class. Right. I mean, I'm in the
No, wait.
afternoon.
There's only one.
Yeah, I got the.
No, there was two, but one was close enough.
I got the. Yeah, that's a nice. That's the class I got.
I don't think I have either one of those, but I'm scared.
Like more
We have like four.
Professor Vu?
I've never heard of it.
so do you know
Until you do the surveys.
you should all like bring that class solution.
I wish I was in that class. I got the late and got the 230 to 320 class.
I think I have it.
That's the class I got. Oh, I'm so mad.
Okay, guys, this is your answer for E, if you want it.
The question I got, we just mentioned like earlier,
Yeah.
about how
There's a really good explanation in the book, but I have to look for it.
so electric, like when the electrons are the same.
Yeah, when your electron configuration is the same, you either lost electrons to get to that noble gas configuration or you gained it.
So I just want to make sure I'm right. So like if the electron configurations for two atoms are the same, the atom that has more protons will have a smaller radius because it has a greater pull on those outer electrons.
Should be, yeah. I mean, logically, yes.
Yeah. Because like I would think it has more protons, so there are more particles in total. Meaning
Yeah.
it's larger, but it's like
hmm
you
There's
look at
more
it sort of
pull.
like magnetic.
Okay, next question. What is the maximum number of electrons in an atom that can have the following set of quantum numbers?
Wait, oh, can you please explain this like in detail? I have no idea.
Is that 3?
Like quantum numbers.
Yes, I can explain quantum numbers.
I hope not, 'cause I don't know.
Wait, yeah.
Yes,
that
yes,
sounds
you
familiar.
do. Yes, some special.
That's their effective nuclear charge.
Yeah, yeah.
Okay.
It has the same trend of ionization.
Oh, it would just be like what's missing.
Yeah, because effective nuclear charge is when it makes it smaller. Like it's pulling them. Effective nuclear charge is your proton
Oh, it's
pulling
being
on your
pulled in,
electron.
right?
Okay, so where was you? Why have I never seen you? Why have we never studied together?
I thought effective nuclear charge was like related to shielding, where like an
Yeah, well, it's
atom
the
would be
proton
shielded.
pulling on the electron, but the reason that like shielding affects, like it's part of effective.
Or is it? Oh, okay. I
'Cause
thought-
shielding can
I thought
block.
Shielding was caused by it.
See, now study with you, I could
Shielding,
have had a better grasp.
The,
of it.
okay, so
I would have had
there's like a nuclear charge, and then there's an effective nuclear charge, and the effective nuclear charge will be like a little lower because it'll be shielded by the electrons around the nucleus.
basically, yeah. The chances of them asking you that, I'm pretty sure
Okay.
I didn't see any of that. I'm like,
So let's stick with like high yield stuff.
yeah.
Wait,
Okay,
Wait, I have a question
yeah.
on this question. The L, well, you're gonna explain it anyway, or is this supposed to be flipped where ML is negative 2 and L is 2? Because
I think it's just the other way around.
I was
Yeah,
like,
yeah.
tripping. I was like, wait,
Yeah, my bad.
Wait, so how do these work? Like what is each thing?
no, I was on 14 to do a switch. L and ML. Because I was like, ML can't be negative. L can't be negative. ML is.
Oh.
But usually I'm like, okay, like
Okay. So N is specifying the orbital,
The primary.
So okay, yeah.
the level it's in. What is it called?
The energy level?
Yeah, that's what I
Yeah.
was saying. Can't have no more than 3 electrons. I don't think it's
No, I think it has 5. What is that 5?
Wait, wait, what? What's the question?
MS is given.
It's asking
Yes, the answer for that question is 1.
Wait, no, what,
This,
how do you go about
the maximum number of electrons.
how to find the answer for this question? The moment they give you a spin, there's, I can't talk over everyone.
Yeah, can you just go through like the one question, and we can see how you do.
Yeah. Okay. So the answer for this question is 1 because the moment they specify a spin, they're talking about 1 electron. Because only 1 electron can have that spin with these numbers. Does that make sense?
But if they didn't have that spin, would it have been 5? Because it would be, 2,
Yeah.
1, 0, like it was, okay. I was interested.
No, that would be 10.
Oh,
Because 2 for each. Yeah. So L is going to be n minus 1, right? So you can have 0, 1, or 2. So this is going to represent the different shapes. This is going to be SPD. Right? So, and then ML is going to be, so for, say N was 2, that means your L is 1. That means you'd have like negative 1, 1.
And 0. What? You have 0 as well.
Like ML is, yeah. So you just take L, it's going to be,
It's like negative 1, 0, 1.
so if it was 0, it's going to be 0. If it's 1, it's going to be negative 1, 0, 1. If it's 2,
Negative 2, yeah.
like that, right? So each of these are specifying 2 different electrons.
Okay, and L was n minus 1.
Yeah, sorry, it's kind of,
No, it's fine.
it,
So in the ML where it's like -1, 0, 1, each of those individual things is like one box that has.
right, for the electron configuration, so it'd be like,
This is the part I'm not understanding what the numbers mean.
so like,
No, it's just space. I do know that.
if you think about it like this, you know how when you're doing electron configuration, you have 10 boxes for D?
Yeah.
Basically, so you know that if N is 3, that means L is 2, right, which is the shape of D.
Okay.
And then if this is 2, that means ML is going to be -2, -1, 0, 1, 2, right?
Wait.
Those are your possible numbers.
So when L has different shapes associated.
Yes.
So and it can only be like what's the highest L can go up to?
For us, up to
No, it
Should be, yeah,
What's the highest that can?
should be 3.
4. Isn't it 14 for F? So it'd be
do you think we'll
It should be, for L, you wouldn't be dealing with anything over 3 because, like, that's,
Okay.
we're dealing with F is, like, the biggest shape, if you want to say it like that. Yeah.
Okay, and then ML.
So ML is going to be, say they said that ML is, or L is 2, then you could have all of these possible things, right?
Okay, wait. So L is 2 means that is a P. P or
D. Because 0 is S and 1 is P.
okay.
So we know that these are all the possible values for D, right? And if you think about it, each one of these represents 2 different electrons. Because each one of these can have one that spins a certain way, right? So you have 5 of these times 2 electrons. That gives you 10 for D, which fits the periodic table where you have 1, 2, 3, 4, like you have 10 in the D block.
Yeah.
Does that make sense?
So it's kind of like an address.
Basically.
Yeah. Okay, what's N?
N is your orbital, like it's like your energy level.
That's okay, this is the part of that.
So is N the energy level, L is angular, ML is momentum, and then it's MS no quantum,
Spin.
and MS is spin.
Yeah.
Okay.
So wait, but like what is this all trying to say?
This is saying what electron it is, where your electron is.
Okay,
It's like an address for the electron, yeah.
N is 3. What does 3 mean?
It's like,
So that's like
Energy level, L tells, okay,
That's
ML
like-
tells you your orbital. Each orbital has 2 electrons.
It-
Basically, if you're given MS, it's 1 electron. If you're given ML, it's 2 electrons. And if you're given L, you do the possibility thing.
those are like your energy levels. Say that's your nucleus of the, wait, that's not, yeah.
so it's like the row. N is like the row. So if N
Yeah,
is 3,
basically.
we're talking about the row.
Kind of.
So like if it's NL is like if NL is like 3p, we're talking about 3p over here.
No.
I wouldn't, you don't really relate it directly back to the periodic table, but you can tell, like, you can think about it conceptually when you think about how many electrons are in the D, like the D block.
Okay.
Because there are 10 electrons, like, you can have 10 here.
How many electrons can like this hold?
Oh yeah.
That, you're talking about the question?
Okay. But maybe just like go on and figure out how to bring it back.
So, like, if they said N equals 3, L equals 2, ML equals -1, that's going to specify 2 different electrons, right? Because the specific one could have either spin, because they didn't specify MS. But once they specify what MS is, they told you which electron it is specifically. So that specifies one specific electron. Because, like, okay, you have your D block, right? Your electrons look like that.
Well, if why are we in the default?
L is 2.
L equals 2.
So those are your 10 electrons, right? This is your plus 1/2 and your minus 1/2. And if L is 2, then you can think about it like that, if that helps.
So what, I still don't get the 3. Like N equals 3. But
They're just telling you that's the energy level you're in.
do we have to know that for everything?
You use it for like Rydberg's like to figure out change in energy, but other than that, you don't really use it.
What's the one where it's like how many like will be in this outer shell? Like how do you figure it out?
Can we just count? We would just know.
Wait, are you talking about that problem where it,
I don't know exactly what you're talking about.
like it'll be like, yeah, it'll be like, don't erase that. It'll be like, and so n equals 3, and what's the other one? L equals, like, sorry.
Well, that would be easy to find out, right? Because then you just do like L is n minus 4.
Yeah.
No, I guess I was thinking about like shells and stuff. Like, I don't know.
I don't really know, but that's like the gist of it. If that helped.
I'm sorry, we sort of hijacked your lesson.
A little bit, but that's okay, I guess. Okay.
Sorry, I'm just like really confused. Like, not really sure how to
You've been
ask
very
it, but I
helpful.
don't know. Okay, cool. Or like all these people that get like random rearrangements.
He said it, not me. Okay. What orbital is an electron with an angular momentum quantum number of 3 in? So we know that angular momentum quantum number is L, right? So L is specifying the shape. So if L equals 3, that means it's F, right? Because 0 is S, 1 is P, 2 is D, 3 is F. Okay. Calculate the frequency of light that has a wavelength of 472.
The answer was just F.
Yeah.
The orbital is F.
Yeah.
Yeah, I just didn't know that. Like F was like important. And then is it like S is 1?
S is 0.
Okay. So F can hold like 14 electrons.
Right. So you think about it. If L is 3, ML can be any of these, right? Wait, I skipped a lot of numbers. Wait, I skipped 1. So
What does ML mean again? It's your orbital.
So there were like 7 in total.
And each orbital holds a plus half or a minus half.
Okay. No, I'm just gonna use the one.
what?
That's why I can hold 14. It has 7, so each orbital holds 4.
Okay, so that was
I don't remember exactly what it stands for.
okay.
But, okay, we get 14 because there are 7 different options from this, right?
Yeah.
And each have 2 electrons because of different spins. So 7 times 2, 14.
Yes, I get it now.
You get it?
That was like how everything met.
Yes. Okay.
Thank you.
Okay. On to the next question. So they have given us a wavelength of 472. Nanometers. We want to change that to meters because speed of light is given in meters.
Whenever I do scientific notation in my calculator, like I always get the wrong exponent.
Use parentheses in your calculator.
Whole thing, like
Yeah.
parentheses 3 times 10 to the 8th parentheses.
Like, I'll write it out. Okay, so you'd write it like this. That is in one parentheses, and then this is in one parentheses. So if you calculate that out, you should get 6.356.
And C will
C is our constant.
is not
I don't think anything is really given.
I think you do get a formula sheet. It's small though. I don't know if the speed of light's on there, but you get a sheet.
You guys probably get R values, right? Or no?
No, you don't get anything.
They just give us specific.
This is a formula sheet. I don't know how to project it. Okay, let's see.
So we get a formula sheet for this?
No.
But don't be hyped because they may not give you everything.
It's not like a helpful.
Well, yeah, it's on there. Apparently, you look at that on the practice.
On this one, they have the gas constants, so they have R. They have all three different R's, so like the ones with different units. They give you Avogadro's number. Yeah, that's the one.
It has to speed up light.
It does? Oh, is it down?
At the bottom. It's at the bottom, right over temperature for Celsius.
I don't see that. I think we have different ones.
Specific, ATM, Celsius, and then there's a C.
Is it on, then give it, is this the formula?
We have different ones, I think.
I'm looking at one from his practice.
It was the right one, but it was the next problem.
Okay, I'm gonna finish these up so you guys can go.
That's more than helpful. Except this, and I don't know that, but the rest of that. Oh yeah, I can add this.
Okay. 17 says, what is the energy in joules of one photon of radiation that has a wavelength of 0.34? So we know our wavelength is 0.34 meters. So this is the time we use this equation because we don't know our, you can, like, there's also this, right? But we don't have our frequency, so we're going to put in into this so we get that.
H is the Rydberg.
No, H is Planck's. Oh, Rydberg is the one with the.
So you were saying we don't have frequency, so we have to get frequency by using the wavelength.
Right. So you're just substituting this into here to get that.
Is the fact that it's a
You're trying to find energy for this one. 18.
What number this is?
17.
Oh, so that's the,
We just did 16.
Why is constant the exponents?
What's the fraction equivalent to negative 14?
The units, meters squared, kilograms over seconds. Okay, so that's your answer for 17. Okay, 18. Yeah, it is. Calculate the wavelength of light emitted when an electron of the hydrogen atom falls for a principal energy level of n equals 5 to n equals 2. So the change in energy So that's our energy change. But they asked for the wavelength. So this we have to use the same equation that we used before.
So energy change and then that energy formula uses are the same.
Huh?
So the E that's represented in the change in energy and the formula to find energy they're the same.
Yeah.
Okay.
So you just plug that in here. And you should get an answer of 1.282 times 10 to the negative 6 meters. Is your wavelength.
So for the one where it's like calculate the energy change, it'll always give you like N of
Yeah.
that and then you just plug it
Mm-hmm.
A question, when the lines are going away, that is absorption, and when the lines are coming back to ground, it's emission, right? Because I feel like, I remember the thing, it looks like it's always opposite when you explain it.
Oh, yeah.
I think so, yeah.
I don't know.
But I'm.
I thought going up is easier.
That's what I thought
That's
too, but
human, but that's not.
yeah, it's the other way to explain it.
Oh, yeah, because when it relaxes down, it emits the light
Okay.
for some reason. But I remember that's in one of his videos about fireworks. Like what's like the energy.
Energy is emitted when it goes from 3 to 2.
So when it goes down.
Yeah.
Energy.
And
Because
when
like,
when is it the biggest? Because we had a thing where it was bigger when it was like from 6 to 5 or 6 to 1 was the biggest.
I think.
6 to 1 would be bigger.
Oh, I think I know what you guys are talking about. So it's like a bunch of lines,
yeah, yeah,
and it's like which one has the shortest wavelength, which one has the longest.
yeah.
Yeah.
So the longest one has the shortest wavelength.
Oh,
Was it
yeah.
because it's indirectly proportional or it's proportional
Yeah.
to each other?
So something going from 6 to 5 is going to be smaller than something going from 3 to 2.
So basically,
Because-
it has higher energy, and high energy looks like this,
Yeah.
so the wavelength is smaller. When wavelength is bigger, that's low energy because like it's stretched out. and slow.
I don't know how to draw this exact. Okay, basically, like, if that's n equals 1,
What?
you said, okay, you said it's beautiful, and then you said you were kidding. Okay, so if you look at it like this, n to 2 to 1 is a bigger difference, and
Oh, okay.
because this is a bigger gap than that is.
As you go up,
As you go up, it gets smaller.
Okay.
Wait, I forget. Going down is absorption.
Going down is emitting.
Yeah, going down is emitting.
Is there a way to remember?
Yeah, that makes sense.
I know it's so.
I don't know.
Yeah. But if they ask you something like that, would they give you that picture or no? You just have to know.
You needed that? I have it written down if you want it on paper.
No, what about when it's like which one is bigger, like 5 to 4, or like 3 to 1?
Whichever was the biggest difference, so like 5 to 4 would be 1, but 5 to 2 would be a three number, so you would do 5 minus the number. But if they give, but they'll probably give you a picture.
They would.
But if they don't, you would just adapt it to the value.
Well, in what situation does it go up? It goes up when it's like hit by a particle.
What?
The energy goes up. Like the energy will go up if the atom is like hit by something, right?
I guess, yeah.
Like a photon or something. Or no, it's when it's hit by an electron and then it emits a photon. Like it's hit by something and then
I
it,
think so, yeah.
like shoot something back up.
Because it'll jump up in energy level.
Yeah.
Because you're giving it energy, it's going to jump up.
Yeah. So that's how I still remember like it's absorbing that thing that it's hit by.
Yeah. Okay. Number 19. Describe the trends for atomic radii, ionic radii, and electronegativity. So atomic radius is going to increase going this way. And it's going to increase going this way. Ionic radius, it's going to have two different trends, like for cations and anions. So increase this way. And they're the same trends, but it stops in the middle. Ionic radius is when it's in its ion form. So that's where you'd have like Ca2 plus instead of Ca.
What's the difference between the atomic and the atomic? Those two next to each other on the right.
So this would be like comparing Ca, and this would be comparing like Ca2 plus.
Yeah, it's same.
It's like the same, but like you can't compare something on this side to this side because this is going to be
On the left side, like,
they're like
both the same, but you should like.
right, yeah.
I can just look at it like this.
Yeah?
And
You mean
you
like
don't have
this?
to worry about, yeah,
Yeah,
you don't have to worry about any of the other things.
basically.
Wait a minute. So, for atomic, okay, so it decreased going down.
It increases.
And it
So it increased going both ways?
So it's the opposite of the less magnitude.
Yeah, basically.
Why does that increase
So
both
atomic
ways?
They do.
atomic radii is the only thing.
So it increases going down and it increases going this way.
Yeah.
So if you go this way in the periodic table, you're going to be increasing.
Like, or going up.
It's gonna take a bunch of prayer for me to pass. We're saying A to get an A.
Yeah, just like draw. So,
I don't know, but I have an A.
Yeah. Okay, next question. Yeah. Okay, which of the following atoms is larger in size? O2 minus or O? O2 minus is larger because you think about it, you're adding 2 electrons to it. So Ca2 plus or Ca? Because you're taking 2 away. And then, yeah, because you're adding electrons, so.
Wait, that's the end.
Yep. What? Thanks. Do you guys want to fill out surveys / evaluations?
If we did it online, you have to do that.
Nah, I think you're good.
Remember, you made us do that.
These are no, these are different. These are I forgot it was that one.
Everyone give all excellent.
Ca2 plus.
Well, thanks.
Excellent
You would
remarks.
think that it's a losing tool.
Oh, what's the second?
Ca is bigger than Ca2 plus. And then
There's
So
a,
wait, the more electrons,
Um,
the bigger it is. Okay, thank you.
yeah.
Just make sure.
These both increase this way.
Yes, but this one, like, when you're looking at a periodic table, you compare the cations and the anions differently. Because, like, do you have a periodic table with you? I can use. I'm just gonna steal this. Okay. So when you're looking at this side, when you have your ions, right, you're taking electrons away, so it's gonna get smaller. Whereas on this side, you're adding electrons, so it's gonna get bigger. So you can't compare like something on this side really with something on that side and have like a general trend. They would be like specific. So that's why like
Would there be a case where it would be like that, or you're just saying we don't do that?
when you're comparing them, yes, but you can't have, you just wouldn't give a general trend to it.
Can you like give an example of a case like that? Because
Like,
I'm
okay,
kind of confused on what you're saying.